Hi everyone, today we're going to continue talking about how to solve different types of log equations. So I have a couple different examples for you that I want to go through, and that'll take care of all the different types of log equations that you'll see. So one of the types of log equations you'll see is when you have just a log on one side. So for example, log base 4 of x plus 3 is equal to 2. And the idea behind this is that once you have a log on one side of your equation, you should take it out of log form and put it into exponential form. So that's the first thing I'm going to do here. Remember, 4 is my base, 2 is my exponent. So I could say here that x plus 3 is equal to 4 squared. And then it becomes a very easy problem to solve, right? X plus 3 is 16, so x is 13. Very straightforward when you're solving it in that manner. Now, that's a very basic version of it, but we might have to do a few things and manipulate the equation before we can get it out of log form and into exponential form, which means we're probably going to have to apply some of the rules, like the product rule, the quotient rule, and the power rule. So for example, if I had, let's see, well, let's try this one. If I have log base 2 of x plus log base 2 of x minus 7, and that's equal to 3, right? The way this is written right now, I can't really take it out of log form because I don't have this one side expressed as a single log. However, because of this addition sign, I can use my product rule and condense this into one single log. Remember, the product rule says that if you take the sum of two logs, that's the same as the log of the product of the two things. So I can rewrite this as log base 2 of x times x minus 7 is equal to 3. And now that I have this written as a single log, I can take it out of log form and write it in exponential form. That would give me x times x minus 7 is equal to 2 to the third, right? And if I were to go ahead and solve that, I have x squared minus 7x is equal to 8. X squared minus 7x minus 8 is 0. And that gives me x minus 8 times x plus 1 is equal to 0. So here I get x is equal to 8 and x is equal to negative 1. Now here's where you have to be careful. Remember that we said way back when we first started talking about logs that you cannot take the log of a negative number. And so what people sometimes do is they get to this point and they automatically reject this answer because it's negative. However, the fact that it's negative here doesn't matter. Where it matters is once you plug it back into the original problem. If it makes either of these components negative, what you're actually taking the log of, then you have to reject it as an answer. Okay, so 8 would be fine because I'd have log base 2 of 8 plus log base 2 of 8 minus 7, which is 1, so that's okay. But if I went ahead and plugged negative 1 in here, I know I'd be taking the log of a negative number, and so I'd have to reject that as a possible solution. And so my only answer here then is x equals 8. Okay, so that's one example of solving a log equation. Is just condensing it down into a single log. Another example would be if you have logs on both sides. So let's say, for example, you have ln of x plus 2 minus ln of 4x minus 3 is equal to ln of 1 over x. So this is actually a little bit more complicated than the last one, but I'm going to start it off the same exact way. I'm going to condense this down into a single log so I can represent this side of my equation as a single log. Here's the quotient rule. So remember, the quotient rule says that I can actually take the ln of the quotient of x plus 2 over 4x minus 3, and that is equal to ln of 1 minus x. And so what happens when you have logs on both sides is basically you can eliminate both of those logs. Okay, what you're actually doing is just like you can take the log of both sides, you can get rid of the log of both sides, basically raising them both to the e power because it's natural log, and that would then just return back those two items. So in essence, all you're actually doing is just getting rid of the log on both sides. Okay? But by equality, these two things have to equal each other. So we end up with x plus 2 over 4x minus 3 is equal to 1 over x. And now it just becomes an algebra problem, right, where you just have to go ahead and solve it. You're going to multiply both sides times, oh, I'm sorry, this probably should be 4x plus 3, otherwise it's not going to work out. Let me go back and change that. Okay. I'm going to multiply both sides of my equation by x times 4x plus 3, which is the same as just as cross multiplying. X times x plus 2 is equal to 4x plus 3. Okay, it means the same thing there. So if we go ahead and solve this, we end up with x squared plus 2x is equal to 4x plus 3, which gives us x squared minus 2x minus 3 equals 0. I end up with x minus 3 and x plus 1. And I get x equals 3 and x equals negative 1. Okay. Once again, you want to go back and check and see if it makes anything negative. The 3 will work in all of these in the original problem. The negative 1 works here. The negative 1 works there, but it doesn't work here and it doesn't work here. It only has to not work in one of them in order to reject that. So I know that negative 1 is not a solution, and my only solution there is x equals 3. Okay, so that's how you would go about solving some of those log equations. Get the one side into a single log represented as a single log, and then either take it out of log form or set both sides equal to each other if you have logs on both sides. There are some applications with these types of things. So when you are solving a problem and your variable is in the exponent, you're going to have to then use logs to solve it. So when you have a problem, for example, when you're dealing with interest or anything like that, and you're trying to solve for your variable. So let's say we have a is equal to p times 1 plus r over n to the nt. This is the formula for compounding interest, depending on what you want to do. Let's say our principal amount is $10,000, and let's say our interest rate is 7%, and we're compounding monthly. Okay, compounding monthly means that that n is going to be 12. Okay, and I wanted to find out how long it will take to grow to, so time to get to 20,000, or the time it's going to take to double my money, basically. Okay, so if I go ahead and substitute all these values in, so I want to know the time to get to 20,000 or to double my money. Sometimes they won't give you this amount. They'll just say, well, how long will it take to double my money? So if I'm starting with 10, the amount I'm looking to end up with is 20,000. I started with 10,000, and I have 1 plus, my interest rate is 7%, I'm compounding monthly, and I'm trying to figure out the amount of time. So the first thing I'm going to do is kind of work this out so I can simplify the equation so it looks a little bit better. So the first thing I'm going to do here is figure this out. So I have 0.07 divided by 12 and plus 1, and that gives me my decimal in here, right? So I have 20,000 is equal to that. Now, 20,000 is equal to 10,000 times, I think it was 1.0058, so 1.0058 to the 12t. Okay, now before I do anything else, what I want to do is I want to get this term with the exponent in it by itself on one side of my equation. So I'm going to divide both sides by 10,000. That's just going to make your life a lot easier. So we end up with 2 is equal to 1.0058 to the 12t. And now, because my variable is in my exponent, I'm going to take the log of both sides. You can do log base 10 or you can do the natural log. Either way is going to give you the same answer. So let's just go with the natural log. So ln of 2 is equal to ln of 1.0058 to the 12t. Now I'm going to use my power rule to bring that exponent out in front so that I get my variable out of the exponent so that I can actually solve for it. So ln of 2 is equal to 12t times ln of 1.0058. I'm going to divide both sides by 12, ln of 1.0058. Do the same over here. 12 ln of 1.0058. Now be careful when you're doing that in your calculator. Make sure you use your parentheses. Otherwise, so close parentheses there. Otherwise, you're going to get the wrong answer. So divided by 12 ln 1.0058. 8. I think it came up 8. There we go. Close the parentheses and enter, and I get this really weird number going on there. So I think what happened was I didn't put my parentheses in right. So you see how you get this really weird answer? It's because I didn't put my parentheses in correctly. So let me do that one more time. ln of 2, close your parentheses, divided by parentheses 12 ln of 1.0058, close parentheses, and close them again, and there is your answer. So see how up here what happened was it just did ln of 2 divided by 12, and then it multiplied that by ln of 1.0058. You have to make sure you put that whole denominator in parentheses. So it would take me, t was 9.98 something, so if I were to round to the nearest amount of time, years, it would take roughly about 10 years. And that's how you do some of those different types of log problems and application problems and log equations. Have a great winter break, everybody. We'll see you in the new year. Take care. Bye-bye.